Hello everyone. Here I am, Himanshu, your physics teacher. We will be having certain sessions regarding some special topic which are very important from NEET perspective as well as application perspective. So we from Sri Chaitanya Gosala Nagar campus, or you can say BS Rao Nagar campus, we are bringing you some important points to understand. Now, I have come here with a topic which is not only important from the exam perspective, but it is also important from the applications perspective, because mechanics, especially the kinematics as well as laws of motion, is one such topic which is not only utilized in the mechanics portion only, it is also used in all other applications of physics. So when we have to study any kind of motion or forces or applications of that, we might be using that particular application. So that's why I'm coming here with an application that is a pseudo force. So when we talk about pseudo force, the word pseudo itself means what? It means something which is fake, like people wear fake smile. So in the same way, there is a situation for the pseudo. Pseudo means something that is fake, something that is not acting in real. So why it is not acting in real? For that, we should understand what kind of frames are there available. We all can relate ourselves with the story that Newton was sitting beside an apple tree and apple fallen on his head, and then he decided what is gravity and all those things. We all have heard that story. But point is that Newton has designed these frames, all these motions or all these applications, all these laws regarding his observations on the ground. So for him, the ground was the frame which was at rest. So based on that, we talk about two different kinds of frame, frame number one and frame number two. So basic frames that we talk about, they are inertial frames and non-inertial frames. Now what is the meaning of inertial and non-inertial? Obviously, a frame where we are saying the laws of motions can be directly applied, like Newton has designed for which frame? Ground. So for us, the ground where laws of motions are directly applicable are what kind of frames? They are inertial frames. Another thing, if I go ahead, obviously non-inertial means what? Laws of motions cannot be directly applied. Now what is the meaning of directly applied or indirectly applied? So let's come back to one basic conception. Let's take up a frame. Let's say there is a truck. I'll give it a design, but it will not be exactly as the same. So when we talk about this truck is actually traveling with certain accelerations. Now I have two persons with me. Person number one, let's say I always call Sharma ji and Verma ji. So he is Mr. Sharma and he is Mr. Verma. Now these two persons both of them are observing only this block. Now when these two persons are observing this block, I'm asking the questions with them. What is the scenario? If we can understand this thing, automatically all other things will be clear to us. So let's say if I talk to Mr. Sharma is observing that this block is actually inside the truck and the truck is going with an acceleration A. So it means what? This block is also going with an acceleration A. And he has studied Newton's laws, so he will say what? He will say that some force is acting on this block. Now, Mr. Sharma has also studied friction. So, what he will say, that there is a friction force which is acting over here, or some force that is acting over here, and that force is friction. And he will say F is equals to mass of the block into acceleration. This is the version of Mr. Sharma. Then let's listen to our another hero, Mr. Verma. So when I talk to Mr. Verma, what do you see? He says that I don't see any acceleration because he is inside the truck. So inside the truck, he will not be observing anything. He will be thinking, okay, that block is at rest. So according to him, the force is not acting here because there is no acceleration. So he says, Mr. Verma says that acceleration is 0, so force is 0. But I have told you already which force is acting here. It is the friction. Now it will not happen that friction will stop acting because Mr. Verma is seeing it. So it will never happen. That means friction though it is acting. But according to Mr. Verma, acceleration is 0. So F is equals to mass into acceleration. Where acceleration value is 0, that means force has to be 0. So where and why, who is wrong here? That is the problem. So that's why I said that frames are two types of frames. One, where laws of motions can be directly applied. Second, those types of frames where laws of motions cannot be directly applied. So if I talk about this condition, Sharma ji is seeing it from the ground. So he is already saying that F is equals to mass into acceleration. But Verma ji is seeing in this frame, here he can say, okay, friction is present, but still friction is not equals to mass into acceleration. The F force is not equals to mass into acceleration. It means here laws of motions cannot be applied. And when I say laws of motions cannot be applied, it means this frame has now become a non-inertial frame for us. So how this frame will be dealt with then? If suppose I have to see in this frame only, because motion is best observed when it is closer to us. Suppose I am standing inside the lift and there is a pulley inside the lift. I will be better judge when I will be inside the lift and watching the pulley, or I will be better judge when I am seeing from the ground. Obviously from the ground I have to take certain consideration, but inside the pulley I can imagine, inside the lift I can imagine, as well as I can watch it very properly. So that's why I should know how to deal the motion in this frame, and that is where it is important to understand what we have to do. So we started discussing, Sharma ji and Verma ji, he started discussing, and he said let's plan out certain thing. So what will I do is, I will call first of all Verma ji outside. So Verma ji came here and now he is trying to move back into this. So when he is trying to move back, he said let's do one thing. Whatever bodies which are present here, suppose there is a block here, there is a block here, any table is lying here or anything, the moment I will go in this frame, I will say for all the bodies present in this frame, I will apply a imaginary force. And why will I apply? So that I can actually balance the condition, whatever it is there on the ground and whatever is there on this frame. So he will say let's apply M into A force here. Here also let's apply M into A, here also let's apply M into A, here also M into A, here also M into A. Whatever bodies which are present, I will apply M into A force. Now, is this acting in real? No, it is not acting in real. Why I am applying? Let's understand why I am applying. Now, if I ask that Verma ji, what do you observe? So Verma ji is now observing, he is here, he is saying one force M into A here, and one force F is here, and this block is not accelerating. So according to him, what is the net force on the block? Net force is equals to mass of the body into acceleration, which he observed as 0. So net force is 0, and if the net force is 0, that means F minus M into A is equals to 0, or F is equals to M into A. The moment I write this, Let's observe what Mr. Sharma ji observed from the ground. He also observed the same thing what now Mr. Verma ji is also observing. That means now our conditions are okay. Now I can apply laws of motion in this frame. But what we have done? We have done a slight adjustment. What adjustment I have done? When I am shifting myself into the frame, I have to apply an imaginary force which is equals to what? M into A. M means what? Mass of the body. A is what? Acceleration of the frame. Number 2, this force is acting in which direction? This force is acting in the direction which is opposite to the acceleration of the frame. So, let's get back to our previous condition. Inertial frames are those frames where laws of motions are directly applicable, and we have observed the condition. Non-inertial frames are the frames where laws of motion cannot be directly applied. Then how we will apply laws of motion here? Laws of motion can be applied by adding an additional corrective false force or imaginary force. This is not acting in real, we all know. And what is this force? This force, that is the pseudo force, is equals to mass of the body into acceleration of the frame. And I put a minus sign. Minus sign, what does it imply? It implies that it is opposite to acceleration of frame. So now we are very much clear what we have to do. If I go into a frame and I don't apply a pseudo force, I cannot apply laws of motion in that frame. If it is what kind of frame? Non-inertial frame. If it is an inertial frame, I can apply F is equal to m into A. So that means laws of motion cannot be directly applied everywhere. They can be applied only in certain frames. And what are those frames? Are inertial frame. Once we understood this, now the point over here is always very simple. What we had to do is we had to adopt a method when we are observing any motion in a non-inertial frame. Then the first thing I will do before shifting the observer to a non-inertial frame, we will say apply a pseudo force, and that pseudo force will always act in which direction? Opposite to the direction of the frame. Let's go ahead. Which kind of frames are inertial and which kind of frames are non-inertial? I know the method now. Now how do I assess? If you see this example of the truck was accelerating with respect to the ground. Let's take the same case again. If the truck would not have been accelerating, suppose it would have been traveling but with the constant velocity. If its velocity would have been constant, that means what will be the acceleration beta? Acceleration will be 0. And if the acceleration is 0, then what I will be observing, what Mr. Sharma will be observing, he will also be saying F is equals to m into 0. That means F is 0. Similarly, what Mr. Verma will be saying, he is also saying the same thing, F is equals to 0. So now both are correct or not? So both are correct if it is moving with constant velocity. It means what? Only those frames which are in acceleration with respect to ground are non-inertial frame. So how will I identify which frames are non-inertial frames? The frames in acceleration with respect to ground frame. They are non-inertial frame. So now we will have a basic clarity. Number one, what is an inertial and what is a non-inertial? Inertial frames are those where laws of motions can be directly applied. Ground or any other frame moving with constant velocity with respect to ground is an inertial frame. So, inertial frame, laws of motions are directly applied. Ground frame is an inertial. Any frame moving with the constant velocity with respect to ground is also an inertial frame. Non-inertial frame, laws of motion cannot be directly applied. Here, when we shift into the frame, we have to apply a pseudo force, which is not a real force, which is applied always opposite to the direction of acceleration of the frame. And what is the value of this? Mass of the body into acceleration of the frame. And the third thing, which frames are non-inertial? The frames which are accelerating with respect to ground. Okay, or anywhere we see an acceleration, we will say that situation is always treated as non-inertial conditions. Now let's see some examples. How do we go ahead? Once again, remember this, pseudo force is not a necessity. Any motion can be observed from the ground also and can be solved from ground also. But yes, it is very much helpful in many of the conditions, many. Wherever you will find an accelerating frame, better is go to the frame, go inside the frame and apply pseudo force and deal it in a non-inertial frame. Let's say, for example, I start with a very simple situation. A lift is there. So, let's take the case of a lift. Lift accelerates downward with an acceleration A. Now, the person is standing here. I will say find out its weight. So, when I will try to find out its weight, I will say when my observer goes inside the frame, what he has to do? He has to apply a pseudo force first. So, there will be a pseudo force acting upward. How much will be that pseudo force? M into A. What will be the weight of the body? That will be acting downward, M into G. And a normal reaction will be acting upward. So, effective weight of a person is actually what? Normal reaction on the ground. What is the normal reaction over here? N will be equals to mg minus ma. Obviously, when A is less than G. If A is more than G, then the person will not be here. He will start flying up. So, over here, what is the effective weight? Effective weight is equals to m into G minus A. Second situation. Let's go ahead to consider another case in the lift only. Now, we will see the Atwood machine inside the lift. Let's take this a lift. There is a pulley over here and the blocks are hanging from it. This block is of mass 3 kg. This block is of mass 5 kg. I have to calculate what is the acceleration and what is the tension. Now, this lift is accelerating upward with an acceleration of 2 meter per second square. Let's deal with it. Now, if I see from the ground, what will I observe? Let's understand that better. So, when I see from the ground, I will see this lift is moving upward. Inside the lift, this 5 kg block will be coming down and 3 kg block will be going up. So, I will not be observing the same accelerations here, because normally in Atwood machine what happens? One goes down, another goes up. This acceleration and this acceleration are equal, but in which frame? Ground frame, when the pulley is at rest. Now, this is not a pulley at rest with respect to ground. It is in motion. So, if it is in motion, it is a moving pulley. That means their accelerations will not be equal. You will not say that 5 kg is coming down with an acceleration A and 3 kg is going up with an acceleration A. Why? Because now the pulley is moving. But moving pulley I am observing only from ground. So from the ground it is a moving pulley. But from lift it is what? It is pulley at rest. So over here, the moment I say my condition to see that one block is coming down with an acceleration A, one block is going up with an acceleration A, both conditions will be fulfilled. That means over here what will I say? The moment this person or this observer shifted into this frame, first thing, without any thinking, I have to apply a pseudo force which is 5 into A and 3 into A. Now I have not dealt with any other force right now. Now I have to find out what is the scenario. So let's deal with all other forces. How much force is acting over here? 5G. How much force is acting over here? 3G. Now I will say this is a connected motion occurring like this. That means what is the force which is driving the motion? 5G plus 5A. What is the force which is opposing the motion? 3G plus 3A. So acceleration of this block, that is acceleration of 5 kg block. Now remember, all these accelerations you are calculating where? You are calculating within the lift, because your observer is where? Inside the lift. So obviously they are with respect to lift. Acceleration of 5 kg I will write as net force, that is 5 into G plus A minus 3 into G plus A divided by total mass, that is 8. So how much it is? 2 into G plus A by 8. What is G? 10, A is 2, 12 divided by 8. So how much it is? 3 meter per second square. 12 to the 24 by 8, that is 3 meter per second square. So acceleration of 5 kg is 3 meter per second square downward. Acceleration of 3 kg is equals to 3 meter per second square upward. But all these accelerations are with respect to the lift. Let's take another case to observe the motion better. Achha, one thing that is left out is tension. Let's write down the tension also. Tension is an intermediate force between these two blocks which are connected already. So intermediate force, how do I calculate? M1 F2 plus M2 F1 divided by M1 plus M2 total mass. It is a reverse weighted average. So over here, what is the force? This is, let us say, M1 and this is F1. This is M2, this is F2. So what will be the tension? Tension will be equals to 5 into G plus A, F1 into M2, M2 is 3, plus 3 into G plus A into 5 divided by total mass, that is 8. So that's how we will try to deal with this frame. Let's take another example. A very common problem that we solve, and it is a very simple way to understand. A wedge is there at an angle theta. A block is placed over it. This wedge is smooth. If I apply a force in this direction, for what value of force this small m block does not slide? Obviously, once again, this sliding from where you will not see, because when we are trying to observe the motion, there are two different kinds of frame. We will always try to identify that which frame I have to deal with. I'm seeing the motion from the ground or I'm seeing the motion from the frame, different frame, which is an accelerated frame. So let's assume if I see from the ground, what will I observe? I will observe this wedge is moving, and this is obviously at rest on the wedge, but it is also moving with respect to ground or not. So I will see an acceleration of this block A in this direction. So I am seeing an acceleration here. But if I see from the wedge here, from ground, I will observe acceleration, horizontal acceleration. From this frame, I will observe rest. Now, obviously, which condition is to solve better? Obviously, if the block is at rest, I have to just equate the force. So, what will I do? I will be dealing the motion from this frame. Always analyze yourself that from which frame I have to observe the motion. Wherever you find comfortable, you go in that frame. Most commonly, the motions are always better in non-inertial frame, betterly observed. So, let's go ahead over here. What will I say? This is the block. The moment I will go in this frame, it is a non-inertial frame. First thing I have to do is, I have to apply a pseudo force. So, this is a pseudo force that I have applied, M into A. Because I am assuming this wedge is accelerating with an acceleration A. Now, mg is in what direction, beta? Downward. Normal reaction is in what direction, beta? Normal reaction is in this direction. Now I have to balance because this is already at rest. So obviously I can resolve the forces and I can identify. So tell me which force it will be and which direction force it will be. So over here, this angle is how much? This angle, if I go ahead, this angle is, this is the inclined plane, this is the angle theta. So obviously this angle is theta. If this angle is theta, then this angle is also theta. So I will say n cos theta here and n sin theta here. Now n sin theta will be equals to what, beta? M into A, and n cos theta will be equals to what, beta? M into G. If I divide both, I will get tan theta equals to A by G, or A equals to G tan theta. Very common problem, but this is a way of dealing with the problems. Remember, once again I am telling you, what we have to do is, whenever we are dealing with a pseudo force or any kind of frame which is an accelerating frame, first of all decide from where you want to observe the motion. Let's take another example where we will be talking about the kinematics of this also. Suppose I give you a condition a truck is accelerating with an acceleration of 4 meter per second square. A block is placed at this end and the length of the truck is 20 meter. Coefficient of friction, now I am including friction also, it is 0.2. In how much time this block will fall from the truck? So time to fall from truck, that is what we have to calculate. Once again, I will start with the same question. What is my first question? From where I should observe the motion. Now, if I try to observe the motion from the ground, what will I see? From the ground, I will see this truck is moving somewhere in a forward direction, and this block is slightly coming in this direction. Now I don't know what is that observation. So net acceleration may be here or may be backward, depending on it is sliding forward with the fast way or it is sliding forward slow. So if it is moving faster, then obviously might be possible it is traveling more distance backward and less distance forward, then it is backward net value. If it is traveling less distance backward and more distance forward, the net effect is forward. But I don't know, because until as the numerical data is given, I will not be able to understand. So obviously there is a confusing state as of now from the ground, although I can solve this motion from the ground also. So what will I do is, I will go back to the same frame. Now this frame is what kind of frame? It is a non-inertial frame. The moment I go in non-inertial frame, what I have to do? I have to apply a pseudo force, and this force is how much beta? M into acceleration A. Apart from this, what has to be done? Now the moment I say I am applying M into A, I am observing the motion where? I am observing the motion with respect to truck. So now every motion I am dealing as of now, it is inside the truck. So I will see whatever acceleration that is coming also, it is also with respect to truck. So over here, obviously friction force, because this block has sliding tendency in this direction, so friction force will be acting here. Now what is the limiting value of friction? Limiting value of the friction will be mu into normal, which is a vertical situation. So normal is equals to how much? M into G. Now what is this value beta? Mu is 0.2, so 0.2 into mg, which is equals to 2m. Now see here, friction maximum value is 2m, but the force acting over here is m into a, which is actually how much? 4m. So which force is more? 4m is more, 2m is less. That means what will be the acceleration of the block with respect to truck? It will be 4m minus 2m is the net force divided by mass is m, that is equals to 2 meter per second square. And once I know the acceleration, I can go ahead and find out what is the scenario. The time is equals to root over 2 into s relative in the frame divided by a relative in the frame. So what is the relative distance it has to travel? 20 meter. What is the relative acceleration it has in the frame? 2. So how much it will be? Root over 2 into 20 divided by 2, that is root 20 seconds. You take any kind of condition, the process remains same. The process remains that first of all I have to observe which kind of motion is happening, and second thing, from which frame I am observing the motion. The identification of frame is very important. Once we identify the frame, automatically if it is an inertial, I will go without pseudo force. If it is a non-inertial, then obviously I will be going with a pseudo force. Let me give you one more example. Suppose there is a trolley. It has one block here and another block here. See, I am dealing from the perspective of the questions which can be asked in the final NEET exam. So I can make the questions little bit complex also, but NEET only focuses on more amount of speed and accuracy rather than giving you a typical kind of problems which has multiple use of the concepts. So here I am giving you a simpler problem. There is this is a smooth surface over here. Now this mass is, let us say, 2 kg, this mass is, let us say, 4 kg. With what acceleration this wedge should be moving? Here the friction is rough mu is equals to 0.2. Here is also rough, mu is equals to 0.3. Now I have to find out what should be the acceleration so that this system does not move. So acceleration such that system does not move. So you take any kind of condition, I have to follow the same situation. That is, whenever we are talking about frame, what kind of frame we are going into, and we are looking the motion. So obviously I'll be looking the motion not from the ground, from this frame. So I'm observing the motion with respect to frame of wedge. Now when I observe the motion with respect to the frame of the wedge, how will I deal with it? What are the forces? First thing, before going to the frame, I have to apply a pseudo force here, that is 4 into A. I have to apply a pseudo force here, that is 2 into A. Now based on this, other forces. So let's see the other forces. Over here, when this pseudo force is acting, there will be a normal reaction in this direction. There will be mg in this direction. For this block, mg will be in this direction. Normal reaction will be in this direction. I am not writing the friction right now. We will understand the friction and then we will write. So here we have got this as 4g. This is normal. This is normal, this is 2g. Okay. Now let's take this system, because I have to only worry about this system. So if I see this system, this is one block, this is the pulley, this is the block. Over here I am having 4g here. Over here I am having 2a already here. Normal reaction over here, this is 2g. Normal reaction over here, this is 4a, and friction I have to write yet. So now this block will slide downward, that means the friction over here will be acting upward. This block will slide in this direction, so friction will be acting in this direction. For the minimum acceleration, this condition will be limiting. So over here, for limiting condition, this friction will be how much beta? Mu into 4a. And this friction will be how much? Mu into n, that is 2g. Now the system will be going like this. So for me, what is the driving force and what is the opposing force? For system not to accelerate, driving force must be equal to opposing force. So driving force is how much beta? This 4g is driving, rest all the force. See, this force is along the motion, this is opposite to the motion, this is opposite to the motion, this is opposite to the motion. So all other forces are opposite to the motion. That means I will write simply 4g is equals to mu into 4a, mu 1. Mu is how much? 0.2. So it is 0.2 into 4a plus here 2a plus mu over here is 0.3 into 2g. That is the net force. I can calculate the acceleration. So how much it will be beta? 4g minus 0.6g. So 4 minus 0.6 is equals to 3.4 g is equals to, this is how much? 0.8 plus 2, so 2.8 a. What will be the acceleration? Acceleration is 34 g divided by 28, which is actually 17 by 14 g. So these are the conditions, and this is how we have to see. We have discussed a little bit complex problem also, easier problems also. One thing is sure, whenever we are dealing with pseudo force or inertial or non-inertial frame, decide the frame first, then go into the non-inertial frame. In the non-inertial frame, you have to apply a corrective force, that is the pseudo force, and then deal with the motion as usual that we do. Hope you would have understood the concept of pseudo force, and the same thing has to be applied. We can take n number of numerous examples, but the concept understanding is all about this. Let's see in the next session, we will come out with some other topic to give you a brief idea about how to attempt the things in the exam. Okay, wish you all the best. Good luck.